Hello friends, today we are going to see about an interesting topic that was called Transformers. The Transformer. Um, Transformer is an art picture. It was released by Google mm, in the paper called as Attention is all you need. This was the paper released by Google in 2017. They proposed a transformer model. By using that, we can do some NLP tasks like let's take transformer as a black box. As a black box, we do not know what is inside the transformer. It's like a black box. We can consider as a black box. We give an output and we get an we give an input and we will get an output. For example, uh, there is a machine translation. We are building a machine translation application using this transformer. By using this transformer model, whenever we give a input in one language and we will get the output in other language. For example, we built a transformer model that can translate French sentence into English sentence. Uh, let's be giving an input in a French sentence like Je suis étudiant. This is an French sentence. We give us an input to the transformer. We will translate that sentence into English. For this sentence, the English sentence is I am I am a student. Like this only, the transformer will do some NLP operations. We can train this transformer for many applications. Like we can train a transformer for translating one sentence one sentence that in a some language we can use a transformer to translate a sentence into other language. Like this example, or we can train a transformer to summarize the entire sentence. For example, we're giving a 100 lines of sentence. We need to summarize it by when the transformer will summarize the overall sentence into a 5 to 10 lines. Like that, the transformer will do some operations. And we can use transformer um, to detect whether the sentence is sensitive or not. Like the sentence, uh, the form of the, it can detect the form of the sentence, like a sentiment analysis. It can be used for sentiment analysis applications. We can train it. Okay. Uh, okay. We can go through inside what is inside the transformer. Um, Before transformer, there are so many NLP models on there. Uh, Before the transformer, like RNN and LSTM. Uh, these architectures are used in LLM, but there is some disadvantage in that. That was it cannot understand the exact meaning. Like let's take an example. Another sentence. we have a sentence like the animal does not does not cross cross the street because it was too tired. We give this sentence to one NLP architecture, like there is old architecture before transformer. There is some architecture like RNN and LSTM are there. Whenever giving this input to the RNN or LSTM, uh, it cannot understand. It cannot understand what it is referred to. Like we by seeing this, we can understand that the animals that cross the street because it was too tired. This it is referred to this animal, but we can easily understand it as an human. You can understand it, but for for another algorithm like RNN and LSTM, it can understand what is it is referred to. It can be referred to animal or it can be referred to street. It cannot understand like RNN and LSTM are not understand. But to solve this problem, transformer is come to place. A transformer will will understood the relation between the each of the word. Like it can identify that it is referred to the animal, not referred to the stick, because the transformer architecture was created like that, so that it can easily understand um, what it is referred to, whether it is referred to animal or it is referred to street. Okay, let's see what is inside a transformer. How does transformer understand the overall sentence, and how does it give desired desired output for us? Okay, inside a transformer, there are two things are there. Like one is encoder, and another one is decoder. Inside a transformer, there are six encoders and and decoders six. Decoder six. This is the overall transformer. Inside a transformer, there are six encoders and six decoders. We give input to the this is transformer. We give input to the uh, encoder and we get the output from the decoder side. Okay. Inside transformer, there are six decoders and six encoders. What is meant by encoder and decoder, and how does it will work? Let's see. Let's see what inside encoder. Inside the encoder, there are two things. One is feed forward network. We all know about the feed forward network that used in neural network. It is a simple feed forward neural network, and another one is self attention. Self attention. will be there. And we will give the input. We will give the input to the first uh, first part of encoder. I told that there are six encoder. There are stacked one by one like this. There are six encoders. They are stacked one by one. We give the input to the first encoder, and we get the output from last decoder. From the last decoder. Let's see. There are six decoder will be there. Like encoder, the decoder also stacked one by one, and last encoder output will be given to all the decoders. The sixth encoder output will be given to all the decoders. Like this only, the transformer block will be there, and we will get the output from last decoder, sixth decoder. Decoder, 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 and there are six decoder will be there. Okay. Inside encoder, there will be two things. One is feed forward, feed forward network, and then other one is self attention. Before giving the input to the first encoder, the in first step, in first step, the input, the input sentence is first converted into numerical vector, because yeah, a machine does not understand the human language. It only understands the numbers. So we convert the birds into numbers by using some embedded technique. Some embedded technique. X1. This first word of sentence is X1, and second word of sentence is X2, and this was X3. Okay. Initially, the first step of transformer is the input are converted into some dimension using embedding technique. Here, here we use word to wet embedding technique. Word to wet embedding technique. By using word to wet, it will convert the word into vectors of 5 told 5 told vectors. It will convert the word into vector with a dimension of 5 told. With a dimension of 5 told. Basically, word to word can convert the words into vector with the n number of dimensions. For, for this architecture, this word to vec will convert the word into vector with a dimension of 512. Initially, the words are converted into vector and then using some position encoders, position encode, then the the words are given to position encoder. This position encoder will 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 save or it can memorize the position of each word, position of each word, because uh, whenever, for example, we take an example, I am a student. These are four words. I am should be come after I. Like that, a transformer, the model should know where each word should be put. So they need to understand each portion of the word so that the portion in using portion encoding, this model will understand each word where it should be present in a sentence. Okay, this embedded word is given into the after this word are converted into numerics, numerical vectors. It will be given to portion encoding. The portion encoding will memorize the portion of each word, and then it given to first encoder. The first encoder will have two things: one self attention and feed forward. A feed forward is a normal neural network. It has some weights. It has some input layer and the output layer. It is a normal feed forward network. Okay, but we does not know what is inside the self attention model. In self attention model, in self attention model, it is the main reason. We already saw that a transformer will understand the each word and what is it is mean by and the relationship between each word. A transformer will understand the relationship between each word. But how does it will know about the relationship? The main thing for the reason is this self attention uh, block. Because of this self attention block, it can understand uh, the relation between each word and each word what is referred to. Like that, it can understand. Inside each transformer, each self attention block, self attention block, the um, some mathematical uh, uh, calculation will be happen inside them. Inside the self attention, um, there is some mathematical block concept will be happen. That was soft max, soft max of soft max of q into kt divided by square root of dk into weights of v. This was the mathematical computation will be done inside a self-attention. Self-attention. But how does it will happen? Let's see. Input like like um, like thinking machine. They give sentence to the transformer to an encoder. First backup encoder. It was thinking machine. Then embedding will be happen after applying embedding. The words are converted into some vectors like x1 and x2 of 5-fold dimension, 5-fold dimension, and then there are inside the self attention there are three weights. There are three weights. One is queries, keys, and values. Okay, there are three weights. These three weights are called as self attention. Basically, these three weights are called as self attention. The first one is W weight Q weight key and weight value. Each each word of vector will multiply 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 with this. For example, this is multiplied with this and it will give some output that will be stored in Q1. Q1. This each vector is multiplied with this weight and it will be saved like this. Then K1, K2, and this vector is multiplied with this WK and save like this. Okay. Then this to generate key vector, we need to multiply this embedded x1 with weight wk and it will store the in key k1 and then next two is multiply with wk and save it as a vector in k2. Like this v1 and v2 also happen. Then we need to um, calculate the score. There will be a mechanism inside that a score will be calculated. That was q1 into k1 and then q2 into k2. That means these both are multiplied. Q1 and q2 are multiplied and uh, q1 and k1 is multiplied and q2 and k2 are multiplied and and a score will be recorded. After calculating score, we will divide the score by divide the score by 8. Why this way? Because um, this 512 is this 512 dimension is after multiplying with this weight, the Q1 dimension will be 64 dimension. The Q1 and Q1, K1 and Q2 these vectors are in a form of 64 dimension um, because the 64 is found by 8 into 8 is equal to 64, because we divide the score by 8. That means uh, q1 into k1 divided by 8, it will get it will have, for example, this k1 and k2 is get 112, and this q2 and q2 is 96 means, and after dividing this we will get 14 and 12. After a softmax function will be applied for that. After applying softmax function for this 14, we will get a 0.88 like that, and then 0.2 we will get this. So after applying this softmax function, the overall, after adding these overall values, we will get it is totally one. We will get a totally one. For after adding uh, score divided by 8 of each word, we will get overall 1. And then the softmax value is, the softmax is multiplied with value. The value is this value. The softmax output will be multiplied with this value, because we already see that first the q1 qt will be multiplied divided by a divisor of a, and then after applying transformer softmax, and the values multiplied with b. After multiplying with b, we will get another vector, another vector, another vector. Then this both v1 and v2 is summed together, like to form z1. This is v1 plus v2, and there will be z2 will be there. Like this summation was happened, and then this z value is, this z value is, this z value is concat together. This z1, and this was, sorry, z1, z2 are concat together and form a attention head. This overall z1 and z2 adding, we will get we will say this as attention head. This after calculating this z1 values, this will look like this. This overall z score is called as attention attention head. After after that after that it will multiply with weight. Multiply with weight means after this was the overall computational computation begin the transformer. After the computing Z1 and Z2, and then we concatenate it, and they give that output to the neural network. The neural network has some weights, and then so that with that weight, this Z value is it multiplied with the given to the feed forward net. Sorry, this is it. Finally, this Z is multiplied with a new weight of W0. After that, we will get a final output of Z, and then it will be given to the feed forward network, feed forward network. By this only, then this feed forward network will gather the information about the words and store it as a weight. This is this mathematical concept will be happen inside the encoder. That each encoder will calculate that each encoder will do self attention and undo undo feed forward calculation, and then it 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 provide the output to the another encoder, like that it will be happen, and sixth encoder will give the output to the all the decoders. What is we see that what is inside the encoders, the same thing will be there inside a decoder, but 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 inside a decoder, not only self attention it will be there. uh, Inside that decoder, masked self attention will be there. Masked self attention will be there. uh, inside decoder only self attention and feed forward network will be there. But in decoder, addition of these two extra, there will be one layer is there. That was feed forward network, feed forward network, multi multi attention and masked multi attention. Masked multi attention will be there inside a decoder. In encoder, the self attention is called as multi attention, not as self attention. It called as multi attention. The same thing is present inside a decoder, but masked self attention will be there. By doing this calculation, the transformer will understand the sentence and give the desired output. This is the overall architecture of transformer. We can see further things, further architecture by using this base as by using this um, base base as taking this architecture as a base. The GPT 3, 4 are come up, and there are also Google list the architecture is called BER. But this is an another architecture. But in this, there are only encoders will be there. And Chat GPT, it is encoder based architecture. And Chat GPT, Chat GPT as a architecture of uses a model called GPT. Inside the GPT, it is found by using only decoders. Uh, this is the overall architecture of transformer. We can see many more things related to generative AI in upcoming classes. Thank you.